Hey everybody, let me switch over to the main screen right here. Let's do it. Went to the wrong screen right there. So I don't know if you're here right now, but if you're watching this in the future, I'm going through the lab right now so you can kind of see how to do stuff and we can explain it. Got a little punch out in the background. Just gotta make sure we click the right screen when we start up next time. I had it all set up ready to go and then I clicked the wrong screen. Whoops, that's the mute myself button. There's the Mega Man button. That's the Mega Man button. It's hard to see around the corner. I've got the buttons to lower all the sounds and stuff. So, if you're watching this right now in the future, hello future, we've got right here the analytics lab. We've got some packages that we might be using, and I just want to kind of explain what these packages are. So let's talk about these packages right here. We've got reg class. Reg class is the regression class package. You can install it if you don't have it. These all will install here. This is like downloading a video game to your computer. Lubridate is for dates. It's a really amazing package. It's a Hadley Wickham package. And so there's Lubridate, and that's for dates. Like when we talk about dates, we're talking about like, you know, January, February, March, 2020. Yay, great year 2020. Jokes. And so this right here does not load the package. It just installs it. So please note the difference between downloading a package and loading up a package. When you load up a package, you're actually running library. So what is the difference between installed up packages and library? Well, installed up packages, you really only need to run once unless you reload R, because it's like kind of like rebooting your, not rebooting your computer, but like doing a fresh install on your computer, like wiping your computer, installing it, starting all over. If you reinstall R, a lot of times you'll lose your packages because it'll like set R to the base R and you'll have to put your packages back on because you kind of like wiped R out and then you have to redo the packages. So I've had to do that before some semesters. So wonder students are like, Brian hasn't even used this package. He doesn't have it installed. Well, probably because right before the semester I was like, no, I had it installed and then I updated R. So Lubridate is for dates, and we go here and this turns it on. It's already on, and cool. I didn't know this for a while. You can go here and you can actually look inside of it and see all the different functions or data packages it brought. So we can change from the global environment to look at the packages, such as like reg class. If you notice, reg class is not on right now. It's not in here. Here's all like the base R packages that are loaded up, like stats, graphics, utilities, base. That's definitely base R. And we're going to go here after this. We're going to go library. And we're going to go reg class. Now you'll notice the package right here at the very top is reg class, and you can see all the functions inside of reg class by viewing this. I didn't know this for the longest time. I just click stuff, and someone told me, hey, if you click that, you can see what reg class has inside of it. And I was like, whoa, no way. That's so much easier. VIF, that's variance inflation factor. Visualize, what are these visualize? Visualize model, visualize relationship. So you can see all those different functions. And of course, you want to know what a function does, you can go down here and go to visualize model. And then it'll give you the what it does down here in the help menu. So there's lots of good ways we can kind of teach ourselves how to do it, but it just takes time and practice. Mice is for missingness. It's a really cool package. So mice, we'll go ahead and install it. I don't think I have mice installed on this right now because I just put R 4.0 on this. And I need to update my R Studio still. I'm going to probably try to remember to do that after this because I think my older R Studio is causing some issues. A rules is for association rules. So I don't think we have many questions on the first activity related to that, but that's association rules. That's what the A rules stands for in A rules. So we'll go here to library, A rules. And you don't have to turn them on now. They're probably turned on later in the assignment. But once I've done this, I'm probably just going to delete these off because they're installed. I'm just triple clicking the lines. I'll never have to do that again. So if this is my own personal document, maybe if I'm not sending it to people, I'm going to remove those out because now whenever I load this document up, I'm just going to run this chunk right here, and that's how you run a chunk. If you notice, it just runs the chunk. And so knowing these little things right here. Just real briefly, this is a chunk of code. So a chunk is where we actually do coding. It's initialized within here with the R. If you delete this, you'll totally mess up the chunk. Look, the chunk stuff is gone. You need that R right there, which tells it it's an R chunk, and then we can magically make those buttons appear again. This right here is the name of the chunk. So you can call this like name of chunk. If you notice down there, it's changing the name of the chunk right here to name of chunk. We'll just keep it what it was. There we go. And it's easy to search through with this icon right here. Include equals false means this is not going to be included. It's not going to include the output, I believe. Eval equals false means this will not be evaluated. So if you did knit this, it won't include this. And the reason being, and so this might be a bit of a problem. Watch out because I'll make changes. Like I'm going to change eval here to true. This will evaluate now, and include means it won't show it when it knits. But the reason I wanted to change this to eval equals true is I changed it from installing the packages, which you can't knit to a document. That's a huge note right there. You cannot knit if you try to install packages. It's like trying to install a package into a Word document. Ours like, no, you can't do that. But since I changed these to library, I'm just going to make it eval equals true here, and I'm going to let it load up the libraries. So understanding what's going on right here is very important, that these are kind of the settings for the chunk. Include equals false means it won't include it, like it won't show it. Eval equals true means it will evaluate the code still. If you set eval equals false, it won't show it and it won't evaluate it. You could do include equals true and then it'll show it, but it won't evaluate it. So you can see here like show it, but don't evaluate it. Show it and evaluate it. Don't show it, but do evaluate it. Don't show it and don't evaluate it. So I probably want to do that right there. I want it to evaluate now. You can also change the settings right here. So you could change to show nothing but run code. So there you go, show nothing but run code. Eval true is on, show nothing, don't run code. See eval equals false. So it's kind of nice. It'll do these settings for you depending. You see the order kind of switch. Doesn't matter, it'll still do it. Show code and output, echo equals true. Echo shows the code. And then include, echo means it'll show the code. Trying to get sure, and then output, show output only. So that'll only show, oh yes, okay. So echo shows the output, include shows the code, and then eval evaluates it. Little things to remember. If you just notice here, show output, echo show output only. So echo equals false. That echoes the code. Oh, there's so many little things to remember. Usually the only one I try to remember, a lot of times I'll just use those buttons sometimes. Oh, look, it shows you all of them. Why not show me them again? Eval, and there you go. And hopefully, it's not showing it. But I'll do eval equals true or false. And ours is so nice. It's got the autocomplete. But if you don't want something to evaluate, you just do that. You tell it not to evaluate. And then echo right there is going to, once again, we can just double check, make sure we say it right. Show output only. So this is only going to show the output. Echo echoes the code. So echo will show you the code, and then include will not include this when it runs. So it won't even run it then. Include equals false won't even run it. So you won't get anything. So there we go right there. And echo equals false will just not show it. So this will run in the background right now if we run it. And we could do a test of this. Never hurts to do a quick test to make sure we got it. To do a test of this, let's try to make our own document right here just to test the theory that echo equals false. Let's go here to echo equals false. And so we should get right here. No, false. There we go. Got to one more. Really? It's not my day. And then we're going to go here to, library, reg class, and we're going to go to data and survey 10. And then we're going to go down here to this chunk right here, and we're going to go summary, and let's go survey 10, and then $gender. And so now let's go ahead and take a look at what this does right here. We're going to knit to HTML, and we're just going to call this testing a theory, a game theory. And then we get it, and let's take a look. So if you notice down here, we do have the output from the individual, and it does work. So what happened here is this right here where the cars was at, you don't see it. You don't see this right here. We shouldn't see anything from it. That's not where the packages were loaded. This is, oh, no, it's showing the output from it. It's just not showing the code. Let's do, include equals false. And let's run this. This might break it though. HTML. Yeah, now it doesn't include it. It doesn't include the output. So echo and include, just small things right there. But if you do this, this will break it. Eval equals false, which is the most common one I use. This will probably just tell us it won't knit. Yeah, it won't knit. The reason this won't knit, and this has happened to many people, this is a common knitting error, is because down here, this is something from reg class. So you'll notice right here the options, how it changes your output, whether it's echo, include, or eval. Probably eval is the most important one because you might just want something not to evaluate, especially if something won't knit. You can just turn eval equals false, but be careful, that could break code below. So understanding what's going on right here, very important. This is the settings for the chunk. It'll change these for you. There's the name, so good. Show warnings, show messages. So you can see you can change that right there. Show messages. So cool. They've updated this so much. You used to have to do it all manually. Use page tables. I have no idea what that even does. Use custom figure. I don't even know what that does. There's so many options, chunk options. There, we should read up on that. So we're going to click away from that. This runs all chunks above right here. So this is the run all chunks above. There are no chunks above this, but if there was, it would run all chunks above. If you notice, it does nothing. That's the run all chunks above. You run current chunk or run all chunks above. Very common. If you go down to the end of your assignment, if you've completed it, you could just go here and run all chunks above, and look, there's a lot of errors because we haven't even done any of it. So that's a really good overview of what chunks are. I'm going to put timestamps in this video so people can see. So this first part of the video is, what do the chunks do? What is an R chunk? This is an R chunk right here. It runs our code. This is not an R chunk. Don't do your code inside of this. This is not an R chunk. Let's take a look at the first question for 474 right here and see what we got going on. So the first question is, were you in class? You are allowed to do these online, so don't worry about that. You are in class if you're doing it online. Make a table of the day of the month for each date. How often is the least frequency? This is the first one, right? It is. Make a table, Q11A. Make a table of the day of the month, 1 through 31, for each date. How often does the least frequently day appear in the data? Note the frequency is very far below the second least frequency, so we want the least frequent date. So we got to go in here and we got to grab some date data. Let's go ahead and grab some date data. We'll see if anyone ever appears in chat. That'd be awesome. So online retailer data, we got it. There it is. There's LubriDate. Get working directory. Hopefully I downloaded this and put it up. We got to change our working directory. 2 seconds. Changing the working directory. Setting the working directory. Choose directory. And we need to be in the downloads because I just download straight to the thing. All right, we got the working directory in the downloads. And let's go back here. Let's try it out. If you notice, my file was not available. Still not available. Ooh, got to get that retailer file. Let's go grab that retailer file from online. Common error right here. So we should have, this is under, let me go back. Retailer, did I not put it in here? And here we go, there's that. Oh, we need to get the retailer file. Well, let me go online and put the retailer file in here. It should have been in here, but it's not. See, all these little things can occur. It's a good thing that we're doing this now. So we're going to go grab the retailer file, and I will put it here online to make sure it's there. Let's go grab it. Retailer has been found. Let's grab the retailer file. I have it downloaded. Let me go put it into the activity now. So we're going to go see it appear in the activity. You'll get to see where it's at too. Retailer has been downloaded. And let's go here and retailer file. And let's put the retailer file online. I could have probably done it this way. Retailer. There it is right there. Retailer. And I think we've done it. Save. Save to the file. Okay. So if you're looking for the retailer file, it is right here right now. So there's the retailer file. I have downloaded it. It should be in my working directory because I set it to my downloads, which I do a lot of times. It's just easiest because I'd be switching classes. Cross your fingers. Always cross your fingers before you run code in R, and it works. So the reason that it wasn't working is because the file was not in my working directory. Go to your files and then make sure it is in your working directory. Now here's another problem too. And you can go to session, set working directory, choose working directory to make sure you're in the right working directory. This is a huge thing right here. This section of the video needs to be called how to make sure your files load. 1, you need to make sure that your RMD, the file you have open at the top, is in your working directory. I like to work out of downloads. It's probably bad. I should be more organized than that. But you need to make sure that your RMD and your CSV files or whatever you're trying to load, whether it be Excel, .dat files, anything, tables, your files and your RMD need to be in the same working directory. I can't say that enough. My RMD is in my downloads and my CSV is in my downloads. Both of those need to be in your working directory. And my downloads is my working directory right now. It's just the easiest thing for me to do. It's not good organization. But don't worry, if it works, it works. That's how we do things. So you can see get working directory right here, downloads, StatTool1 downloads. So this is my current working directory right here, and both files are located inside of there. So this code runs. If it's not running and you're like, I swear I have it, here's what you need to do. You need to close down R completely. Close down RStudio. And then when you close down RStudio, double-click the file inside of the working directory. Like double-click the file that is inside of here to boot up RStudio. and that'll set this directory to your working directory. And then as long as the other file is there, as long as your retailer.csv is there, it'll work. If it doesn't work, please email me. We'll hop on like Zoom or something, and we'll get it to work. Very common problem. Some people have emailed me, Brian, for 3 hours, I've been trying to get this to work. Don't worry. Once you realize how it works, you're good. Okay, so we got the retailer data right here. The answer's already entered. Did I do the answer? Oh, solution set. What am I doing? Why did I go to the solution set? What fun is that? What fun is that to do the solutions? Activity 1. Let me see here. What have I done? I've showed all the answers. I guess we need to go back here. Data validation. For some reason, I feel like this is the second activity. Activity 1, submissions. We will get to this. I might actually move the activity to Tuesday as I look at this because we'll have a lot to cover on Monday. So it is on dates. And then did I just download the wrong? Here it is right here. Here's the lab, date validation. And let's open up this right here. Here we go. Now we don't have the answers. Yay, let's not look at the answers. Here we go. Okay, what fun is it with the answers? We want to actually do it ourselves. Okay, so let's take a look at date validation right here. We've got the data set loaded in, and we actually want to look at the retailer data. We're going to hop back here and go to the global environment as our, seriously our, it's trying to trick me. It's haunted. Let's go here and look at the retail. Wow, look at this. 135,000 observations. I'm on a pretty good computer, so it loads up pretty quick. You can just take a look at the whole data set. Cool, we understand it now. We know what's going on. It's also a great thing about R is it can handle like larger data sets. You can just imagine Excel trying to do that. R uses resources a little bit better than Excel. We're gonna go here to retailer. We're gonna look at the date inside of here, and here's the date. Messy, messy, messy dates. But what is the format? And I will say this, a lot of times we might not show all of it. Here's a code we should know. We should know a code like head. Head right here shows the first 6 observations. So it by default shows the first 6. And when you run it, there you go, first 6 observations. Or you could show like the first 4 observations. You could show the first observation. If you want to go to tail, this will show the last observations. And so we could go to tail 5 or 6. And these are the last observations. Now what you need to do is you need to look at this. You need to look at this format right here. 5/13/2013, 1/16. Now 5/13, that gives it away too. It's month, day, year. So we're going to go here and we're going to call a function month, day, year. Now don't always call month, day, year. Why did I choose month, day, year? Like slow down right here and be like, why did Brian choose month, day, year? Why did we choose month, day, year? The reason we chose month, day, year is because the date's in the format month, day, year. That's why. That's why it's in the format month, day, year. So we go right here and we simply go retailer. And then you go this and you put inside of it and that changes it. Now what we're going to do is we're going to overwrite. And if you notice, I looked at this. I made sure it's correct now. This is now in, it changed the order a little bit, but it recognized it. And we could even go back and look at the first few dates in here, all the way back up to the top. So if you look at this right here, we've got 9/24/2012. And so let's go ahead and run head on this again. And then there's 9/24/2012. So that confirms we have the same thing. We could even double check right here and just go 1 to 6. That's another way. It is a vector, right? Yep. And there's the first 6 changed. And we're using brackets now, or square brackets, to call positions to make sure we're seeing the same thing. All I'm doing in this moment is confirming before I overwrite it. I want to make sure I don't mess up the date because I'm going to go here and I'm going to overwrite it. So now I'm overwriting what is in the date. I'm like saving on top of it. So if I make a mistake here, there's no undo button. Once I do this, there's no undo. There's no going back. Okay, there's no going back. We did it. So right here, this overwrote what we had. And I just want to make very clear. The reason we chose month, day, year, and some people just always use month, day, year. No, 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 no. What if we had dates like the following? If we had dates right here, and this is what I was thinking about, like 12 dash, yeah, could that be good? 12 dash, try to think, 12-8-2020. And then we go here, and then this one is 20-01-2019. So right here, this would be day, month, year. And so if you look, here's what it looks like now, but we put it inside of the function day, month, year. And we just go here, and just knowing how lubridate works like that. And now it has turned it into dates. This is actually a date format. Yeah, they're supposed to be available. It's to help you out. They're always up. It's like the activities are just meant to kind of learn, and they're basically free grades. Great to see you, Andrew. Lubridate is so fun. Andrew, watch this. Give me a date, like how you would write a date. I just want you to write a date in the chat. Like, watch this. I could put in here, Jan 12, 1988, like that. I could put Jan 12, 1988. And I'm going to put that inside of here, inside of quotes. And then I'm going to figure out the format. So this is month, day, year. Do you see how it's month, day, year? Because it's month, day, year. And then when I run this, it turns it into that. You see me vote? There we go. So Andrew's giving me a completely different format. I put this inside of here. I check its format. That is day, month, year. And then I run it, and it turns it into a date. So it's really good. Like, you could have, like, you could put X's between this or whatever you want. Oh, it didn't like it. Oh, no, it's not supposed to break. Lubridate, you're supposed to be better than that. I bet if we did this, I bet it would recognize this. You can do it, Lubridate. You can do it. It did it. It's pretty good at figuring stuff out. It'll fail sometimes, but it's pretty good at figuring out what's going on. So it can, like, parse dates and figure out date text. Probably if someone did like this right here, I bet it'll do it. Nope, didn't like it. Oh, because those, I think, are special characters. We're up there. That worked. So it's pretty good at figuring stuff out. There can be messy special characters and stuff. It can obviously break, but you have to figure out the format. But even better yet, if you were to do something like this right here, you could go to this and go to hour minute. Is that one of the things? Yep, I think so. Does that do it? Nope. Put in quotes. I think hour minute is one of the things in Lubridate. There we go. There's hour and minutes, 12 hours, 30 minutes in Lubridate. So that turns it into hours, minutes, and you could add on to its seconds, I guess. Like that right there. Oh, it doesn't like that. Does it have to be point? Oh, because hour, minute, second. I got to add the second on it. There we go. So someone might record time like this. There's 20 hours, 30 minutes, and 50 seconds right there. So you can literally have something like this right here. And let's go here, hours, minutes, seconds. And it didn't like that. Could not find functions, day, month, year, hour, minute, second. Day, month, year, hour. Oh, it's underscore. There we go. There it is right there. So if you look at this right here, there's the function day, month, year, hour, minute, second. And if someone was recording like sales on a site, and as long as you can keep, and actually it can parse similar formats, but it has to be in the same order. But why did I use DMYHMS? Because this is how the data was put in. It was put in day, month, year, hour, minute, second. And you can look at the different formats like day, month, year, hour, minute, second. You can look at month, day, year, and there's month, day, year, hour, minute, second. I guess no one mixes up the hour, minute, second. It'd be weird. Year, month, day, year, day, month. There it is right there. Just all these functions are pretty easily to figure out what they are. Month, day, year. What have we not done? Year, day, month. Year, month, day. Month, day, year. Month, year, day. Oh, there's no month, year, day. No one does that format. Day, month, year. Day, year, month. Oh, there's no day, year, month. Oh, no, there it is. Day, year, month. Day, year, month, hour. There's no day, year, month, just hour? That's weird. See, these are all Lubridate, but just understanding that you have to actually look at this. I have too many students who always assume you use day, month, year, just because we might do it for an assignment, or month, day, year. Because they'll be like, oh, it's always month, day, year. And it's like, no, you have to look at it. You have to look at this and say, this is the day, because you can't have 20 months. And this is the month. So this is day, month, year right here. And this is day, month, year, hour, minute, second. Pretty easy to use the package. And once we've overwritten what we want, we can start doing it. What did the question say to us to do again? The question said, make a table of the day of the month for each date. Okay, let's take a look. Basically, this will give it away. So we're going to make a table right here of the day of the month. So actually, I think it's month. Where is it? No, it's mday. That's what it is. Mday is the function right here, and this is in the notes. But you could have 20 months. Andrew, you can't have 20 months. You can't have 20 months. So this is month day right here. That's what this stands for. And we're going to go to the retailer data set. We're going to call date. And there it is. And we just want to turn this into a table now. So we go here and we just turn this into a table. And boom, we got a table. That's the table. And I'm not going to tell you the answer, but you can sort it. You just go to table sort. Why? Try to figure out the most common. And then if this is least to greatest, well, you could put, is it decreasing? There it is, decreasing equals true. Now it does that. And I don't know if you want to find the second least or you want to find the least. You can just do that. It's going to report for you the values. But this is why we like to code, because we can make mistakes when we do it ourselves. But if you kind of know what to code, you can just ask it to do it for you. You can say, tell me the day of the month, put it into a table, sort it in decreasing order, and tell me the highest one. So you can change this. You could change this to year day. Here's a table of the day of the year. Well, let's look at the full table first. Here's a table of the day of the year for this retailer. Whoa, craziness. Wow, pretty crazy. So we got year day. You could look at weekday, W day. So if you look at these commands right here, did I only report was there only 1 week? W day, weekday. Was it only that they reported in on like Tuesdays or something? So weird. Let's take a look at this. Let's take a look at the data set. So if we look at this, let me look at weekday right here, because even I'm wondering. Weekday, and we want to put in the retailer, and go here, date, and go to label equals true. And did they only report on Mondays? Because I guess Monday is the first day of the week technically for them. And then let's go to table. They're only reporting in on Mondays. So, but there is different observations for different months. We can change this to month right here. And you can see we can look at the different months they reported. We can also look at the different years they reported. I wish it would stop going all the way down. Let me do that. You can look at the different year they reported, and label equals true. There's no label for year because year doesn't have a name to it. So there's the years they reported, starting in 2011, going all the way to 2015. And you can see how quickly we can change this. Just take a look, and you'll see this throughout the lecture, that there's functions like year, just tells you the year, month tells you the month it occurred, mday tells you the day of the month it occurred, yday tells you the day of the year it occurred, wday tells you the day of week it occurred, seconds, it'll tell you how many seconds. There's so many things inside of Lubridate it can do, and it's all time stuff. Lubridate is all about time data. So you can get all of this out of your data. You can tell differences between times. It's really amazing, great package, and just understanding the small nuances of it. If you want to turn like your table into a plot, we could probably plot it. Will that plot for us? Oof, that is quite the plot. Let's go ahead and turn it into a decent looking plot right here. So we got here table plot, decreasing equals true. Weekday, because there's only 1 weekday. That's sad. A month. There we go. And I don't like the way that looks. Let me go bar plot right here. Let me go bar plot. There goes a bar plot. Looks better. And let's go to, I'm going to remove the decreasing equals true on this. And then table month. Inside of month, we want label equals true. So if you notice where I'm writing this, it's very important that this is inside of the month function. So this is an argument inside the month function. I'm currently inside of month putting label equals true, and now it labeled these on the bottom. So there is a bar plot for us of our tables, and I should do this in Ggplot also. You know what I might just do in Ggplot. So I'm gonna throw a Ggplot on here for fun, because I always like showing off a little bit of Ggplot, because why not make this look better? Last but not least, we can give it some color. That's going to be inside the bar plot. And so it should be col equals purple, because everyone loves purple right here. So there you go. It's now purple. It's a purple bar plot. Woo! Awesome. If you want a title of it, you go here to main, and you go to sales by month. And there's that. So now we got a bar plot with a woo, looking awesome, looking good. Got purple. Gotta love some purple. But let's do a Ggplot of it, because I want to have some fun, and I will put labels in this video. So if you're watching this, you can click around and learn how to do different things. But Ggplot Bar Plot. Ggplot is one of my favorite packages. And let's see here. Someone should have a good Ggplot Bar Plot up here. Good. Or let's do Plotly. Why not Plotly? Plotly uses Ggplot. Plotly's like advanced. Plotly Bar Plot in R. Plotly's also in Python, so when you specify and you look up code for it, make sure you get your R code, not your... Okay, good. I think this will do. Okay, is that the code right here? Got it. Okay. So I'm going to take the code that they have. Ooh, they wrote it in a complicated way. Okay, they're saving their X vector, their Y vector. That's the names of the months. That's the data. Okay. So let's go here, and we should be able to manipulate their code to create what we want to see. So I always like trying to make some cool graphics. Oh, what's up, Andrew? Why are you sad, Andrew? What's happening, my man? What's happening, man? What's happening? Did we crash or something? The sad face scares me. Purple. Do you like? Oh, like, I'm sorry, man. I'm sorry. Purple's cool, though. I'm sorry. Okay, so when you look at this right here, let me look at the graphic they made and show it to you. What does their graphic have on it? Just look at the structure of what they've created in this. So they've got product A, product B, product C, and that's that. The text. Oh, that's the overlay text. Okay, we don't need that. So cool, though. We could rep it. We could say sales this month. Yeah, we could rep it. So we're just going to rep sales this month. So that's what we're going to put. When you hover over it, it's going to rep that text below it. Okay, so let me put this back over here as an example so I can see later on. So that's the graphic we're going to... It was just funny. I know. I was like, what did I do, Andrew? Okay, so our text is going to be a rep of... So we need to go here to rep sales this month. Monthly sales. And we're going to rep that 12 times. Okay. Our X vector has to be the names of the months. The easiest way to get the names of the months is going to be to get the... We're going to take our table data right here. So this is just me going crazy on this. We're going to take our table data here. Oops, didn't close it. Didn't close it. There we go. We're going to take our table data right here, and we're going to store it as X for the moment. It's just the smallest thing I can store it into that I can manipulate. And then we're going to go to names of X, because you learned today that tables are a named vector. And we're going to store this into X. So we can just take the names of X right here, and this is the name vector. Just notice how what I created is a vector name, and we don't want that. Then we want the data from the table, so that's created in X. Now we want the data from the table to be a vector. So we're going to take this right here, and we're going to store this into Y for the moment, just capital Y so I can show it. Or let's just run it. I'm going to go to unname on the table. So this is unname, which unnames the table. We're going to take a look, and that's just the numeric data, so that is what we want. We're going to store that into Y right here. I'm hoping this works. I'm crossing my fingers. And then we got this right here, and all we did was change the name of their data. Plotly is probably not running. So we're going to go here to library Plotly, and that's got that. Plotly is now on. Make sure you installed a package as Plotly. And now let's take a look. So a lot of people have been asking me, can you make some cool Plotly graphics? Well, we're going to cross our fingers here and see if this works. That looks good. That looks good. Oh, it's running. It's running. Oh, wait, no. We don't want this. Monthly sales report. Monthly sales report. Okay, let's fix that. Okay. Let's run it. Please work. Oh, it's been doing this. It's been like hanging on the graphic. You can do it, R. You can do it, R. I don't know what. This is why I think I need to update our studio. It's been really grumpy, and it's actually like been taking a lot of memory. I think it's doing it. And I'll have another way to check here in a second. I wonder if I can knit it. So let me do this. Stop run. Oh, wait. Look. You saw it. You saw it. It showed it. You can pause that video. What are you doing, RStudio? This is why I didn't make videos on Plotly, because lately my RStudio has been a little grumpy. Let me zoom in. I think it's done it, because I saw the image blink there. And I can knit it. I've been trying these out, and it does work when I knit. And I'm going to start looking into over this weekend what's going on. Okay. So let's try to knit it real quick. I really want to know what's going on here. Where's my knit button? There's my knit button. I'm going to knit to HTML. You can't knit Plotly graphics to Word documents. And we might get an error message down below. If so, I'm going to delete out that code. We got an error message on line 60. Where's it? Oh, missing X. Let me see where that's at. 2 seconds. I really want this to run. All that's going to run. Let me clear my global environment. This is a way to fix if you can't knit. If you can't knit, if it doesn't knit, run where the code chunk broke. The error message when you try to knit will give you an error message at the start of a chunk. There is no code on line 60. There is no code on line 60. So I have not crashed on line 60. It crashed at the start of line 60 somewhere in this chunk. So I ran all chunks above. I'm going to run this line of code right here. That runs. This runs, this runs. I'm just running each line until it breaks. That runs, that runs, that runs. Oh, these won't run. Yep, okay. That's obvious. Haha, should have just saw that. Okay, those don't run. Everything right here looks to run. Don't put that in there, that'll break it. And then what I'm going to do is, for the moment, I'm going to delete out all code below, because I just want to see this cool graphic. Okay, let's go ahead and give this a shot. Niche HTML, see if it works. Give it a shot. And let's see what we get. Show me my graphic. We worked so hard on it. Here we go. You ready, Andrew? Here we... That's the bar plot. Here's the advanced one. Whoa, here it is. So this is our Plotly graphic right here with the monthly sales reports where we can hover over it and you can actually see the monthly sales for each month. So you can put this on a website right here and do the hover over ability and just imagine this being on your website. It's pretty cool. We could adjust. I wonder if these adjust per page size. They're not adjusting now. You can do them in Shiny also. But yeah, I want it a little bit smaller, so I have to work on the size of this page. But you could have, the great thing about Plotly is you can go here and you can actually like zoom in on the data. So you could actually just view these months right here in your monthly sales report. And I probably would work on making the image a little bit smaller. Can I do that with this? There we go. There we go. Look at that. Now we've zoomed out on it. And there's the monthly sales report. Yeah, that looks nicer, Andrew. You like, it's good graphic? Yeah, I think so too. And it's just cool because you can hover over and you could put these on your website and you could have it update just by grabbing the data. And if you look at this code, looks super complicated, but all I did was change out the names vector, change out the Y vector, and then change out the text that it repped. And then it did it all for me. You've got here the color and then the line going around it. So we could change this. It's calling RGB to do different RGBs. Here's the default we get in R, which is not Plotly. And then here's our Plotly graphic, which has hover over abilities, and we could even zoom in on stuff. So you could grab this right here and zoom in on it and be like, here's this month. Let's isolate these months. So it's really cool graphics. Only took me a few minutes to make. And I will try to update my R Studio because, I don't know, it doesn't like me. It's mad at me. So that covers this question right here. Make a table and report the date. Everyone should get that. Requires some of this. Enter the median value for price for rows that have combined watches categories. The question in the lab.rmd says number of orders, but you're doing the median price instead. So this one's pretty tough right here. We're going to look at the median value of price for rows that have combined watches. Okay, so we're going to combine together all the watches. So I'm probably going to do this one in full because this is tricky. So let's go down here. Oh, I deleted it. Haha, there, it's back now. Okay, cool. So when you look at the categories of sales people have, let's go to the categories of sales. We're going to put together certain categories here, and most important is the watches. So you only have to do parts of the activities. There are the answers to all the activities, and the more you do of it, the more you learn. But let's take a look at the retailer data and see what's going on here. We've got, is it category, price category? Is that, no, that's not right. Is it category? No, what is it called? It is called, what is it called? Product. So what I'm going to do here is this is a good way to investigate data. We'll talk more about data validation in this class. But I'm going to make a table of products right here. And what do we see? We see a lot of repeat products. So this is kind of validating and looking through data. We've got here beauty A, beauty B, beauty C, beauty D. So those are all beauty products. We got electronic B, electronic A, electronics B, electronics. Oh, these are electronics. They're not electronics. They're electronics. And we don't sell many electronics. We only got 15 electronics. We need to up our sales in electronics. Joke over. So all these different things right here. We got home with a capital H and home with a lowercase a. So lowercase h. So there's some data misentry here. There's some data validation issues. This is not a very clean data set. But this is probably one of the most complicated codes we have to learn at the start. And it took me a while to know this one, understand the syntax of it. But what I'm going to do right here is I'm going to create a watches category in the levels vector. So let's go right here. I think this is how we do it. This can get really grumpy really fast. You're going to see some fun. I'm going to go to the levels of this right here. Wait, levels of product. Does it not have product? Oh, is it? It's words, isn't it? Ooh, it's words? It's characters. Okay, cool. I can deal with that a lot easier then. Cool. I'd prefer it to be... So we could take and make it a factor because it doesn't have levels if it's not a factor. So let's go here. Let's overwrite it. And we're going to overwrite it as a factor. And now we can go here. It is now a factor. So we've turned it into a categorical variable, which I prefer it to be. I want it to be a categorical variable. Then we're going to go here and we're going to look at the levels of it. And now it has these levels. And what we're going to do is we're going to go to 26, 27, 28, 29, 30. And I believe we can go to 31. This should produce NA. It produces NA. There's nothing there. Let's see if it lets me write to it. Watches. It lets me write that. Let's take a look at the levels vector again. And if you notice, I just created a watches level. Now, what's interesting is if we go and we make a table of the products now, and I will say this, if you're doing all this work that I'm doing and then you want to knit, delete off your work that's not needed. But if you notice, this does exist now. This watches level I created exists. So what am I going to do? I'm going to start recoding other variables into the watches level. So I'm going to start recoding the other variables into the watches level. And I guess there's another way you could have added this on. I could have appended on. I could have done it that way. But I wrote to level 31 that did not exist. I wrote watches. That worked. That code, it's good. And none of this, remove this. If you are knitting things, if you're doing what I'm doing, delete off stuff like that. Why do I do this kind of code? I do it to confirm that I have what I want. I don't want to show this to people afterwards. So I would clean up my code. That's one thing you don't see me do a lot because I don't have to knit stuff. I'm just writing the code. But you can always delete from your Word documents, but make sure you're showing what needs to be shown, like to get the grade. But then don't flood the screen with output like I'm doing. So you have to worry more about the presentation. I have to worry about writing the code, and then you have to clean it up. So you are getting a lot of help, though. Like, Brian, just show me what to do. Okay, we're good. So we got the table right here. So think about this. Our goal right now is to gather up all of these watches. Our goal right here is to gather up all of these levels. So what am I going to do? I'm going to grab these like this because I don't want to spell them. If you try to spell them, you're going to make an error. You're not going to catch a capital W. You're not going to catch like a capital A, lowercase a. Just copy paste. Copy paste is your friend. Copy paste is your buddy. So we're going to call this old levels. And I'm going to store this right here. I'm going to concatenate first. I'm going to put it there like that. We're going to delete off all these spaces right here. And we're going to go here, put that in. Can we double click? Oh, we can. Hey, that's cool. There we go. We're going to run this. We're going to take a look at it by clicking it and running it to make sure we got what we want. We have what we want. We have the old levels. So this is when it gets tricky. Now what we want to do is we want to recode all the old levels to be called watches. So we're going to recode everything to be called watches. So let's take a look at retailer and let's look at product. Now you should think, what will this produce? This will just print to the screen the vector. That's all the vectors right there. I've got here the old levels. And Andrew, I don't know if you're still watching, but do you know what this code will do? This is something we talked about today. This right here will see if what I'm showing right here, like when I show jewelry, or there's tons of jewelry, when I show something like jewelry, it'll tell me if jewelry is contained in the old levels. It'll tell me if other is contained in the old levels. So this will do a logical check that if this thing over here on the left, because that's what this is contained in this thing over here. So it'll say, is this contained over here? Is this contained over here? Aw, cool, Andrew. Good job. Have some good dinner, man. And look, we get trues and falses. Boom, right here at true. So in the late 900s, we should see a watch or something. So late 900s, do we see a watch? There it is right here. So 983 is a watch A. So let's go here, and that's 983 because that's 984, 983. So this is what this code does. It does a logical check to see if the products we see listed are contained in the old levels. So what am I going to do? I'm going to go right here, and I'm going to call the positions. How do we get positions? You should know this. How am I going to turn trues and falses into the positions of the true? Pause the video. Think about it. I want to get the positions of the true. And you should immediately think, which? Now these are all the numeric positions of the trues. Everywhere there was a true, I now have a position. So now I'm going to go, this is the crazy part that always tricked me. I'm going to go outside of this, and I'm going to go to where those things are at. I'm going to these positions. So when I view this right now, I should see like watch A, watch B, watch C. I should see all of that. And there we go. So now I've gone to the positions of the true and displayed the values inside of them. Last but not least, we're going to overwrite these values with watches. And we've done it. Now I'm going to do something. Hopefully it doesn't explode everything. But let's say I had watches J. I think this will cause an error. Will it cause an error? I think it will. It did. Because watches J level does not exist. I might have just broke my data set. Good thing I just rerun it all. So I might need to reload the product. Let me do this. Run all code above. Everything is running. Hopefully it's going crazy over here. Let me stop the figure from doing its thing. The reason it broke is because there was no watches J level. So this line of code right up here is very important, where I create the watches level, because then I can write to the watches level. I could have also renamed a level and called it watches, but there has to be a watches level to write to the watches level. So if you don't create the watches level, it'll be like, can't create that. And yeah. So now we've created the watches level. Let's see if this is correct. We're going to do a table of retailer product. And let's go here. And here we go. And look, here's all the watches. There we go. And what you can do now, and I think this works, I always forget how this one works a little bit, is drop levels. And did that do it? You have to do this. You have to go drop levels, and then you have to overwrite into it. Is that how you do it? And then you do this. Let me see. So what does drop levels do? It drops the levels. So take a look at my code beforehand and look at what drop levels did. So here's the table beforehand with the zeroed out levels. So the code drop levels, and then you overwrite the data frame with the dropped levels. Will drop the levels in that product. So I overwrote the vector products with dropping the levels that have no levels. So I've removed out those from R's memory. R no longer knows those, and I can't use them as levels anymore. So drop levels erases the levels with zeros. There's tons of codes to know, and you have to keep a little bit of memory of like how the syntax works for each one. But once again, remember, you are just learning. I know you're like, wait a minute, Brian, how am I supposed to know this one? There's all different things, and you're seeing examples of it right now, and I'm doing this to help out, and there will be segments under each part of this video to help out explaining what's going on. So this kind of answers this question. I'm not going to give the full answers to all these, but enter the median value for price for rows that have the combined watches category. We just created that. Enter the median price. There might be NAs. We can find out if there is NAs. Here's a cool code we can do right here to find out if there is NAs, which will... So we want to go to the price. Oh, we want to do it just for those watches. You could subset. You could subset the retailer data set. So we want to subset retailer with product equals to watches. Okay, those are just the watches right here. We'll call this sub for subset. Now we've got our subset, and we want to go here to sub $sign price. There's the prices, and let's look is.na. Are there NAs? These are just checks I'm doing. Are there NAs? And let's do a sum of it. You can sum up NAs because it's trues and falses. When you do it that way, there are no NAs. Okay, you don't got to do na.remove. Just checking to see if you need it. There are no NAs in the prices vector for the subset, and you will have to create a subset of just the watches, and that did this right here. There's other ways. I'm good. I don't need to show you another way. Okay, let's do it real quick. Ready? Here, let's show another way. Real quick, another way. Another way to get just the watches is to go to product. Wait. Oh. Scaring me, phone. I was getting... They said no more coding. Product equals... Whoops. Watches. And so there's those. And so we can go right here. And let's go to retailer. And I want to go to these rows. So I want to go to the rows that have watches for them. And this should create the same data frame right here. Let me take a look. I just want to double check my work. I'm going to call this sub2. And there, yeah, it didn't change. Yeah, if you look right here, sub1 and sub2. So we always say there's multiple ways to do the same code. This is going and taking only the rows where the product has watches. Just kind of looking at this code right here, just try to decode it. We're going into the row space. This is the row space. This is the column space. That's not code meant to work. It's just meant to show you what's going on. Here's the row space. Here's the column space. In the rows, we want only the rows where they have a product equal to watches. So this code right here will tell us if the row had a watch in it. And then we're just taking the rows from the retailer data set. This is blank, meaning we're taking all columns. So you could put like just column 1, and you notice now sub2, I'll turn it into a vector. Now it's a data set. So now it has 2 columns in it. And if I just choose one column, there you go. So we don't want that though. We want all the columns. Gotta go just little bits as you learn it. It's a lot, so don't worry. This is the 474 portion. Please slow it down or please rewatch it. I know I'm hitting you with a lot of code right now. It's just so much fun. There's so many questions. Enter the fraction 0 through 1 of rows that violate the relational constraint of effective orders. In other words, what fraction of rows have values where effective orders plus this are not equal to effective orders? Okay. Try to calculate the answer using the mean. So that's a really good note right there, is that the mean can be used on logicals. The mean can be used on logicals. So let's take a look at this right here. We've got that we want effective TV orders plus effective online orders not equal to total effective orders. Okay, so we've almost got the code we need. This is an easy one. This is easy. So we're going to grab this code right here. We're going to model ours after. We're going to go product or retailer. If I could spell, that would help. And then we're going to go here to effective TV orders right there, plus retailer. And then effective online order. Cool. And that's just a total. We're going to take this and we're just going to put it inside of parentheses because it never hurts to do that. And we're going to do equals not equals to, and then retailer, $ effective orders. Cool. And here it is. Wow, that's a lot of trues right there. Now, you could go through and you could start adding up all these trues. You could just go through and start being like, okay, that's a true, that's a true, that's a true. Now, one thing you need to know, let's talk about logicals here a little bit during this question, is that when R sees trues and falses, I've literally put questions like this on the test and asked people what this solves out to. This is another one of Brian's coding questions that you should get very easily. What is true plus true plus true plus false? Why not? And the answer has not changed. This is equal to 3. That's equal to 3. Because R sees trues and falses as zeros and ones. R sees trues and falses as zeros and ones. So all of these trues right here are ones. So what can you do with a bunch of ones? You could take all of this code right here, put it into parentheses, because we're about to do something with it, and sum it up. And now we know how many trues there were. This is how many trues there were. But you could also, this is a long way, divide by number of rows for the data set. So you could divide by the number of rows, and now you can get a percentage. But like I said, that's the long way, when you can just go here and do the mean of it, and now you get the same number. And I was like, I think there's seen one different one time, because there's some small thing I found one time that creates a small difference sometimes. Because I think the way it does mean and sum can be a little bit different if there's NAs. You have to watch out with those NAs. NAs in the data set can cause havoc. Because there was one data set we were looking at and it had a difference. But take a look at these codes right here. This sums up, let's show it. This right here sums up all the trues that meet the condition. That is the sum of all the things that meet the condition. And then we divide by how many rows there are. But you could just as simply go right here and just take the mean of all the trues. Since it's ones and zeros, it'll tell you the percent of ones there are. So this is the same exact answer as adding up all the trues, which are all ones, and then dividing by how many observations there were, or just figuring out the average amount of trues. And it's very quick just to do the mean right there. So I think I just gave away that answer. I've got where I can look at the answers over here. Did I just give away this answer? Oh, that's not the right one. I've got it over on the side. Did I close it? No, I got it over here. Let me see. Did Brian just give away an answer? Did Brian just give away an answer? Make sure I did it correctly. Uh-oh. It looks like Brian gave away an answer. Dun, dun, dun. And I think it says round it to how many decimal places. Oh, it doesn't. Oh, it's got a margin of error. Good. 4 decimals. You know, when you get an answer like this, just copy paste it. Be like answer, copy, paste, answer, done. So that's got that one done. We have now completed that question right there. We'll talk a little bit more about logicals right here and how R deals with them. Let's talk just a little bit more in this section of the video about logicals. When it comes to logicals, R sees them as ones and zeros. I can't state that enough. And I do put questions like this on the test where I ask you to tell me, like, what would this be right here? You should instantaneously know this if you knew the last one. This is a gimme question on the test. What will this evaluate to if it's run? And the answer is 4 because it sees it as ones and zeros. What about if we do this right here and we go around it and we go to the mean? Now, I don't think it's going to like this right now because I need to put some commas in here to make it, and I need to concatenate it also. So we're going to do the mean of a vector like this. And we're going to concatenate it. And we need to go here and do this. Okay. So what will this do? This is another good test question. What will this code produce as output? There's 5 observations and 4 of them are true. 4 out of 5 is 80%. Understanding what the code does before you run it is the key to knowing how to code. Being like, okay, that tells me the percent of truths. So when you look at this right here, let's do another code in here. We go to survey 10. I need to load my reg class. So library reg class. And then we go right here and we go data survey 10. It appears now because I've loaded reg class. And we go to survey 10 $GPA greater than equal to 3.0. So what will this do? This will tell me the percent of students who had a GPA greater than or equal to a 3.0. That is the percent of students who had a GPA greater than or equal to 3.0. What will this do? This will tell me how many students had a GPA greater than or equal to 3.0. So when you look at this right here, you can use sum and mean to evaluate logical vectors. Once again, this inside of here is creating a logical because it's got the greater than or equal to, and there you go right there. What if I wanted to know what percent of students are left or right-handed? This one's a little bit complicated. I'm going to do handedness, and we're going to go percent in percent, left, comma, right. So that is this will be the sum, which is the amount of students who have a handedness that is contained in left or right. That is how many there are. And then we could go to mean, and there's that. We could easily figure out ambidextrous. It's the remaining one. And I wonder if, I've never tried craziness like this. That's not going to do it. That's not going to do it. Yeah, I thought it wouldn't do it. I've always wanted to do, well, you know what you could do? If you want to find out not, go here and then go this. That flips all the trues and falses. So if you wanted to find out the people who are not left and right-handed, like, I want to find the people who are left and right-handed. Now I want to flip all my trues and falses to not true. To trues will become false, false will become true. Like literally this exclamation point, if you put it in front of a true, it'll turn it to false. So if you have a vector like we had before, I wish we would just grab some of those. Wait, where's our vector? Here's the vector we created. If you were to put an exclamation point around this whole thing, then, whoops, what did I do? Delete that, put that there. This is going to become false, false, true, false, false. So if you notice, that's awesome the way it looks right there. An exclamation point just flips it. So when you look at what I did is I wanted to find the percent of left and right-handed. This is the percent that are not left and right-handed because I said, now give me not that. So it flipped all the trues and falses that were inside of here. Every true became a false, every false became a true. So little quick tricks like this and knowing how logicals are evaluating is very important. There's a lot more to things like this. You can't do equals equals here unless they've changed it. Yep. Or it did something weird. Oh, I know what it did. You don't want to do this. This looks like it ran, but the way it's doing it is it checked the first person to see if they were left-handed, and the second person was checked to see if they were right-handed. And I can tell you this right now without looking. This data set has an odd amount of observations, and there it is right there. It's an odd amount of observations because we got an error saying the object lengths were not the same. If this was an even amount of observations, and I can prove it here by going to survey 10 and deleting off the last observation. So we're going to overwrite survey 10 by deleting off the last row, so minus row 699. And so now you notice there is no row 699, and now when we run this, it actually works. But this is deceptive because this did not do what we wanted it to do. It checked the first person to see if they were left-handed, the second person to see if they were right-handed. The third person was left-handed, fourth person was right-handed. Not saying they are, but it's checking. First person is left-handed, check. Are they? True, false. Second person is right-handed. Are they? True, false. Third person is left-handed. Fourth person is right-handed. Fifth person is left-handed. Sixth person is right-handed. It's checking each one flip-flop, 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 flip-flop. And it's kind of close to about half of what we got originally because, and I guess you get more right-handeds, but we don't want the equals equals. We want percent I in percent, which checks to see if somebody's handedness is contained in the vector left-right. And that's the correct code, and we're seeing if they're not left-handed, not right-handed. So that right there. And so just kind of an important thing right there, knowing with logicals, very, very tricky. But that's a decent review of logicals, and we kind of went a little bit advanced on it. But good thing. Consider the total sold column. What fraction of values are not integers? Woo, this one's a tough one. I'm going to check my answer when I do this one. So you're getting some answers here. This one's tricked me. Is this the one that gets me sometimes? We'll see. We'll find out coming up. Consider the total sold column. Okay, not integers means it's a number 1 through just 1, 2, 3, 4. And a good way to check for an integer is to see if it's divisible by 1. So what we could do is we could take the total sold, and let's go over here. Where's our R code? And let's just go down to a new portion of the code. And let's go retailer. And let's go total sold. Or not. Is that not what it was? Tote sold. Tote. Oh, haha. Tote sold. There we go. Didn't put a dollar sign. And we've got some things that don't look to be integers. So that's a bit of a problem right there. Decimals are carried all crazy. It might be due to me. Cool. So what I'm going to do is I'm going to write a quick code right here. My quick code is going to be %%. That's right? And 1. That should do it. Cool. Got it. So what did I write right here? This tells me the remainder when I divide it by 1. And so if you were to do 5%, %2, what should this get you? It should get you 1, because that's the remainder of 5 when divided by 2. If you do this, what will you get? You'll get 2, because that's the remainder of 5 when you divide it by 3. Let's do another one right here, like let's do 20, and let's do 5. What is the remainder of 20 when you divide it by 5? That should be 0. There you go. % just gets you the remainder of something. So you can check another one like this. That should be a remainder of 2, because 18, then you get a remainder of 2. So it just tells you the remainder. So if something is divisible by 1, what should be its remainder? Its remainder should be equals to 0. So there is the remainders right here. The remainders, true or false. And we should be able to find out, is this the one that acts weird? Is this the one that acts weird? Let me see something. Because I swear there's one of them. There's that. Is this the question that's giving me problems? Nope, there's no NAs, so we should be good. Okay. That's just checking how many A's there are. NAs there are. Just checking a total amount of NAs. There's no amount of NAs because I summed up the trues and falses. And so this logical check right here is about it. And then we just want to know how many there are. I'm giving away answers here, I think. Well, that's the mean. Do I know how many? I typed the code and I don't realize what I typed. Let me look at some answers in the background right here. Consider hint. The value is, so the only integers you have to consider are the ones, sequence. What fraction? The largest value is this. So let me look at. Oh, and then I think I see what I did. Are not integers. Haha. No. Okay. This originally was the amount of integers, so that's the amount of integers, that's the amount of not integers. So it doesn't want the amount of integers, it wants the amount of not integers. Not that I'm giving away the answer, haha, not that that's the answer. But, so if you're watching this video, hopefully you've been learning a lot, but not that that was the answer, wink, wink. So hopefully you're learning what we're doing. And we just got a few more questions here. Read in the Dozer CSV. Is this not in our thing? We gotta get the Dozer CSV file. Okay, let's get that Dozer CSV file on here. So let me get the Dozer CSV file. What have I done? This is good that we're here looking at this. So let's get the Dozer CSV file loaded up. Let's go to the quizzes, the details. Why is that not loaded in here? And we're gonna load in, I am hallucinating because I swear I put in the analytics one. There we go. I think it's because I backtracked and I didn't have it on here originally. And now let's load in the Dozer CSV file. Dozer. And let's load in the file. Let's go here to Files. And Dozer. And there's Dozer CSV. Dozer CSV is now online. So you'll see Dozer CSV just underneath. Please tell me if you ever see an issue like, hey, Brian, this file is not located online. I'll be like, okay, let's get it. Dozer CSV is now downloaded. We've downloaded the Dozer CSV data. We've only got 3 more questions. We got this. This is good. Let's go over here, load in the Dozer CSV file. I'm kind of hopping around. There's so many things to do. But let's load in the Dozer CSV. We might have put it on here somewhere. There's the bulldozer, and here we are. So if you notice, we're just saving it to Dozer right there. And let's go ahead and run this line of code. It does work. Make sure Dozer's in your working directory where I'm currently hovering over. If it doesn't work, please contact me immediately. We'll get it worked out so it does work. Now, what did the question want us to do with the Dozer data? Okay, our chunk at the very top of the problem, part 2. When you have the stick lengths in inches, enter its median values. Oof, this one's tricky. Oof, I'm trying to think how much of this I want to do because this is a tricky one. Yeah, tells you what to do, and I didn't do that. So we have right here that we're going to look at the stick lengths. And the problem is they give us some really messy data. So let's look at this Dozer right here. Stick lengths right here. Wow. Look at this. This is horrible. What is this data right now? So we're just doing some checks on it to see what kind of data it is. It's a character. Oh my gosh. Everybody. And we're going to go to factor right here. And right now we have different factors. Let's look at the levels of this. I'm going to overwrite this as a factor just for the time being. Trying to think. I think, yeah. This one's so messy. This data is just, because I've done this problem multiple times, it's so messy. And I'm always trying to think of better ways. This is kind of what I do to kind of think myself through it. I'm going to overwrite this data right here. Not with the date. We're going to put this data right here. And we're going to overwrite this. Now we've created the variable into a factor. We're going to go right here and go to levels. And we're looking at the different levels. And that is just a mess. But what you can do, and this is probably one of the quickest ways to do it, I would say, is you could turn these into inches right here by overwriting the levels vector. And just making sure if we turn something numeric, will that alphabetize it? No, we have to turn it to a character first. That's what we got to do. Okay, cool. So if you look at the levels vector right here, I'm going to rename all of these into inches. And I'm going to call a thing right here. I'm going to make a function for myself. I'm going to call this inches. There we go. And it'll take two inputs. It'll take the feet, and it'll take the inches. And then it's going to return feet times 12 plus inches. Okay, so what does this do? And there's the lowercase inches, good. So we're going to call this how many inches. It'll autocomplete after, there we go. So I've got a function called how many inches right now, so I don't make a mistake. And the inputs it takes are going to be this. It'd be really cool if I could use I could parse text and do all this cool stuff. But that would take a little longer. So this should tell me, if I'm doing the math right in my head, how many inches should this be? This is right under 11 feet. 11 feet is 108. So this should be 106. Oh, wait a minute. My brain is wrong today. Did I do it wrong? Oh, because wait, that's 120 inches. What am I doing? What am I doing? So this is 120 inches. I was thinking it was 12 was 120. And so this right here should be 122. So this should be 122. And so this just lets me check and make sure I'm getting it right. I can probably do most of them in my head, but little fun function to make. Just tells you how many inches something is right there. And it'd be so cool if I could parse this text and have it do it for me. If you had a bigger thing, it'd be good to write this function and then have it go over each element, do a for loop. You'd have to clean up this text. I kind of want to challenge myself to do that. It's a lot of dealing with strings right here. I'm just looking at it and being could I apply this function over each thing? It'd be painful because you'd have to take. If this was my job, I'd turn this into a function and I'd apply it over the whole vector. But it's not my job right now. The reason I don't want to do it is I don't want to take another 10 minutes. I want to do this problem, and this is a pretty smaller data set. But if this was something I'd do a lot, I'd write a function that would scrape just for the numbers, and then it would. I feel like I'm gonna do this later, but let's do the actual problem. You ready? Okay. So I'm gonna call this new levels. Okay, so new levels right here will be the vector of the following. We're gonna go right here. We're gonna grab all this. And we're gonna have to clean it up. Ugh, it's painful. So this first level right here is now going to be called NA. This is just painful cleaning up data. This is the least fun part. This 1010 we figured out was 130. So that's 130 right here. This we figured out was 122. Be careful because if you put in the wrong thing. And I think it'll let me. Deleted too much. This one right here is 126. about the best way I can figure to do this. 126. And let me overwrite. We'll see what it does when I do this. We'll try to overwrite. We'll see what it does. Okay. This is 132. Someone's going to figure out I made an error on this, because I already couldn't do the first. This is 154. I'm just deleting down and then doing each of the maths. The next one, there it is. This is 152. Be right back, everybody. I could have myself muted while I clean this data, I bet. It's just cleaning data. Oh my gosh. 144 plus 8 is 152. 8 times 12 is... My brain's just breaking right here. 8 times 12 is 96. Plus 10 is 106. If I make an error, it's all wrong. Oh my gosh. This is the worst part ever. 96 plus that is 98. One error and we're all wrong. Just one typo. That's why it's better to do it with code, which I'm not doing with code, but I should. We got it figured out. We got the vector. New levels. Create. Already ran it. Woo! So we got the new levels vector. Be right back. if you saw what just happened in the background there, I was really wondering, was it really this sparse with the data? And the answer is yes, because the amount with the blank level, this is the blank level, which is just the quote level. Way back when, if you remember, we had a quote level that existed, which was the first NA in here. It had 731 observations, and then we have 218 observations here that became this NA. And you can see the different data. As long as I've entered it in the right way, we should be good. And so this should overwrite, but we need to turn it back into levels. My code will run correctly if I turn it into a factor. Good. We don't even have many inches code. And then we wrote our new levels vector. We're overwriting the levels vector with our new levels. We're taking a look at the levels vector. Cool. And we have the NAs in there now. So it is now, when we look at this is the character. And I'm going to take the character, and I'm going to go around character, and I'm going to go as numeric. Now, we need to turn it first into words again, and then we turn the words into numbers. Just to show you right here, if you do not do this, it'll numericize or put them in numeric order. So take a look right here, what happened to the data. This is very, very important, that you have to wrap it this way, where you have to turn it into a character and then into a numeric. We talked about this today, but this is a major, major thing, that if you do it this way, it'll turn it into numbers again. But if you do it this way, it'll turn it into the numeric order, which we don't want the numeric order of the levels. We want the actual characters out of it. So you have to make sure to do it this way right here to get it out. And we're going to put this here, and then we're going to save it into this. And this has it right here. That is looking good. So I'll kind of let you guys do that part from there. But use enter the number of rows. So we just want to look here, enter the number of rows. Oh, we got this. So this right here is using enter the number of rows that have these things but are missing this certain things. So this is missing pattern, or is it MD or MD pattern, missing data pattern. So I'm going to show you a little bit about the missing data package right here, missing data. And let's go down here. So MD pattern is in the mice, and all you do is input the data set you want to look at the missing pattern of, and it'll show you the missing pattern. Now, this is a lot to deal with, so I'm only going to look at dozers for the first 3 columns. So this is, oh, no missing data. You get the cat if you get no missing data. What does it mean if data is missing? It means that there's just values that are missing, and this shows you the pattern of the missingness. Okay, we didn't get the cat now. We're going to zoom in on this graphic. Sometimes it comes out a little bit weird right here. Oh, we're starting to see it. Go away. Let's zoom in on it again. We'll go full screen. Almost. We need to, okay, the last one right there. So this is how you do the MD pattern. That's got missingness good. We can look at this. Oh my gosh. It's so cluttered. I want it to not be off the side of the screen. This graphic is too large sometimes. They need to use Plotly for it. Machine current meter. What are you doing to our thing? So what does this mean right here? When you look at this right here, it's whether or not certain things are missing. And I'm not liking the way it's displaying right now. I think if I use survey 10, we'll get a better view of it. Let me try different variables here. No missing data. Let me do my survey 10 because I know that works. Survey 10, I just don't like how it's displaying right off the screen. Good, we found some missing data. Let's do that. That has no missing data. I thought we found one with missing. Nope, cat's back. If the cat appears, you have no missing data. I found no mice. You just can't find missing data anywhere. But you find missing data there. Oh, it's outside the thing, isn't it? There we go. No missing data. So I thought this one had. Is it survey 11 that has missing data? Finding missing data is hard. Finding those mice in the data, the missing data. So let's go here to survey 11. And now survey 11's loaded in. Let's load missing data pattern. So here we go for survey 11. And there's definitely missing data there. Let's look at only a certain few rows because the graphic gets insane. We're going to only go to, columns. We're going to go to columns 25 through 35 just to narrow it down. It looks like, do we have missing data? No missing data. I swear I've found missing data before. I know it exists. Survey 11 has 51. I think it's towards the end of the survey. Sure, that should have missing data. No missing data. We found there was missing data. 25. You know what? I could do it better. Oh, we found missing data. Here we go. So the mouse did not appear here. He's saying we have missing data. He found those mice. My headphones are just going to keep falling out right here. This is Brian in search of missing data. Yes, we're starting to narrow down where we can see the missing data. And we're starting to see it. Yes, good. That's not that fun pattern. You know what I might do? I'm going to create my own data set. I think you'll understand better. Scrap everything I was doing there. Okay, let's create our own data set. We're going to create a vector here called height. And height's going to have in it these heights. These are ridiculous heights, but these are the heights of the individuals. And then we're going to put an NA there. We have 1, 2, 3, 4, 5, 6, 7. Now we're going to create a weight with a U. And we're going to throw in another missing data right here. Now we're going to create a GPA. I think this will make it much easier to understand what's happening with this when I show it this way. We'll put this in. GPA is going to have all of its values. And then we're going to go in here to grade in a class or something. Grade in a class is going to be all NAs. So if you notice, every value in grade is just going to be missing. Grade is completely missing. So we're then going to turn this into a data frame right here with the function data frame. So data frame can turn things into data frames. The first argument is what do you want to put in your data frame? Next argument is what do you want to put in your data frame? I like to do them on separate lines right here. Next argument, what do you want to put in your data frame? Next argument, what do you want to put in your data frame? It's now a data frame. Height not found. Oh, because I didn't run these. You got to run your code. Now it runs. There we go. If you notice, this has now become a data frame. So what does the data frame function do? Turns things into data frames. Takes your vectors, makes a data frame. Let's store the data frame right here. The data frame has now been stored to the global environment. We have now created a data frame from those vectors. So now that we have the data frame, we can do MD pattern on it, and we won't get a crazy graphic here that's too large to look at. We can look at the following graphic. Look decent. Yes, here we go. So this is the missing data pattern we have. Let's take a look. Do you remember how many times grade was missing where I just input it? Grade is missing 7 times out of all 7. How many times was weight missing? Weight is missing 2 times. How many times is height missing? 1 time. If you're confused, go back and look at the vectors. The vectors are right up here. Here we have grade missing all 7 times, represented by this. Here we have GPA missing 0 times. So GPA is all the way over here with 0 missing. The 1 right here means it's present in all of these. And so it's present in all of these right here. GPA was never missing. That is the total amount of times GPA is missing. Height was missing 1 time, and height was only missing by itself. So when height was missing, it was the only thing. Let me double check right here. No, wait. Height missing, and then also it was missing when GPA and weight were missing. Excuse me. In the 1 row where height was missing, this is the 1 row where height was missing, we also see, because the zeros represent that height is missing, weight is missing, GPA is missing, and the 1 row where height is missing, right here, is also, we have the other ones missing. If you look at the pattern, it's showing you these. And then we have right here, in this 1 row, we have here, we have here that there are 2 things missing, correct? There was 1 row where 2 things were missing. That's what the 2 represents right here. There are 1 rows where 2 things were missing. The 2 things that were missing in the 1 rows was weight and grade. And that is the following one right here. This is the 4th one right here. We can also confirm this by going here, and you see it right here that there is 1 row where 2 things are missing. That is what this is telling us right here, and the 2 things missing were weight and grade. There are 5 rows where just grade is missing. There are 5 rows where just grade is missing. That is this row, this row, this row, this row, and this row. These rows don't count because these rows have 2 things missing. This row does not count because it has 3 things missing. That is the row represented right here where we're missing height, weight, and grade. So if you notice, the 1s and the 0s represent whether or not it is present, and we can see right here how many of the missing values there are. This just counts up the zeros. So this is 3 zeros here. This counts for 2 zeros here. This counts for 1 0 here. We could do a row where everything was present, so let's do that. That'll do a new pattern. So we'll go here to the second observation, and we'll just overwrite this with something like 5, and we'll run this. And now when we look at the missing data pattern, we have this. If you look at all these 1s right here, there is a time where we have everything present. And best probably look this way because this is 1 row where GPA, height, weight, and grade are all present. So that is, it's present. But GPA was present in all of these. So that's why the GPA gets the 1 going down, because GPA is present. There's no pattern where everything's missing. We could throw that in. Let's do a pattern where everything is missing. We'd have to go here to, let's see here. We need GPA to be missing. Let's do the last value. So now we'll lose this pattern right here. It'll become 0, 0, 0 because this row where there was 1 missing, 1 present, is where we're going to see GPA now be missing. So we'll have a 0, 0, 0, 0, 0 pattern. Look at this pattern right here of the missingness. And all you're doing by looking at this graphic right here is getting a visualization of this. And I always have, this graphic sometimes goes off the screen when it gets too large. They need to, whoever made the MD pattern or the mice package, I think that's probably why they made the numeric output, because their graphic is too large a lot of times. I don't know why. I think if you go here to export, I think if you go here to export and export to save image, and we're just going to call it rplot. And now let's go here and let's take a look at rplot. And did it export properly? Oh my gosh, that's not good. Don't put that in your report. Usually, I guess you have to make it bigger, or you can export to PDF. Let's see if I saved a PDF. rplot101. I'm just gonna keep pulling my headphones out of my ear. So rplot01. Let's look at the PDF. Oh, did it do it? Oh, it did it. There we go. And then let's take. Oh, that's the end of it. That's the last one. Talk to you guys later. Bye.